press the bell icon on the YouTube app and never miss another update.
Hello students, welcome to part 29 of chemical bonding. So in the previous class we had gone through the different competitive questions regarding this chemical bonding chapter, and in this class also we will have a continued session regarding the previous session. That is, we are going to solve a different competitive questions on this particular chapter. Okay, the next question will be, so the next question is like that: which of the following hydrogen bonds is relatively weaker? Okay, usually the hydrogen bonding can take place in between hydrogen atom and most electronegative atoms like fluorine, oxygen followed by nitrogen. Means the process of hybridization, it can take place only in between the hydrogen and these three electronegative elements. In our periodic table, so many electronegative elements are there, but the hydrogen bonding which can take place only in between these three electronegative elements along with the hydrogen, not with the other electronegative elements, such that the strength of hydrogen bonding among these three elements varies with the electronegativity difference of these three elements. That means among fluorine, oxygen and nitrogen, the order of their electronegativity follows this order. Fluorine is most electronegative, then oxygen followed by nitrogen. Like that, if we consider the strength of hydrogen bond also, if the hydrogen bond is, the hydrogen atom is bounded with the hydrogen fluoride followed by HO bond followed by HN bond. This is also an hydrogen bond, this is also hydrogen, this is also hydrogen. If the hydrogen bond is formed in between the fluorine atom or oxygen atom or nitrogen atom, the strength of hydrogen bond is maximum in case of hydrogen fluoride because of more electronegative fluorine atom, followed by the strength of HO hydrogen bond is less than that of HF hydrogen bond because of decrease in electronegativity of oxygen atom rather than fluorine atom. Like that, which is the question here, which of the following hydrogen bonds is relatively weaker? When we compare the strength of these hydrogen bonds, HF bond is more stronger, followed by HO bond, followed by HN bond. Which is the weaker bond here? The bond formation takes place between the hydrogen and nitrogen will become the weak bond. So which is the correct option here? Hydrogen with nitrogen. Option 1 will be the correct option, that is NH bond. So the next question. So the next question is, the shape of which of the following can be satisfactorily explained by the directional overlap concept of VBT? Okay, the question is like this: shape of which of the molecule is represented by VBT ಅಂತ ಹೇಳ್ತಾರೆ. ನಾನು ಕ್ಲಾಸ್ ಮಾಡುವಾಗ ಸಾರಿ ಹೇಳಿದ್ದೇನೆ, VBT which is responsible for the geometry of the molecule. Okay, by using the valence bond theory, we can predict the shapes of the we can predict the geometries of the molecules, and we cannot predict the shapes of the molecules. Okay, shapes of the molecules na VBT explain madodilla. That will become the major limitation of VBT, and that limitation was satisfied by VS-EPR theory. Okay, the shape of the molecule has clearly explained under VS-EPR theory and not by valence bond theory. So the question is, the shape of which of the following can be satisfactorily explained anta kelidare, but no molecule's shape is explained by VBT. That is why the correct option will be none of these. Means none of all the molecules were explained under this VBT. VBT is responsible only for the geometry and not for the proper shape of the molecules, okay, which is explained under VS-EPR theory. So which is the correct option here? None of these. Option 4 will be the right one. Okay, next. So the next question: the number of anti-bonding electrons in O2 molecule are the number of anti-bonding electrons in O2 molecule are. This is based on MOT, molecular orbital theory. So in order to find out the number of bonding electrons and number of anti-bonding electrons present in the particular molecule, we have to write the molecular formula or energy level diagrams for this oxygen atom. Okay, how can we write the molecular formula? What sigma 1s, sigma star 1s, sigma 2s followed by sigma star 2s. This is common for both less than or equal to 14 system and greater than 14 electron system. But here the number of electrons present in the oxygen atom are 16. Each oxygen atom will have 8 electrons. We have 2 oxygen atoms here because this is an oxygen molecule which consists of 16 electrons. That means we have to follow the second method, that is greater than 14 electron system and follow up ಮಾಡಬೇಕು, that is 1 2 2 1 system. Okay, after sigma star 2s we will move on with the sigma 2pz followed by 2 stands for what? Pi 2px is equal to pi 2py followed by again 2 stands for pi star 2px is equal to pi star 2py, and after that one more is there, that is sigma star 2pz. For this electronic configuration we have to fill the 16 electrons in order to find out the bonding molecular orbitals and in order to find out the anti-bonding molecular orbitals electrons. Okay, 2 4 6 8 10 12 14, and these two molecular orbitals are having same energy px and py. Okay, that is why we can give each electron to each molecular orbitals, okay, according to Hund's rule of multiplicity. Okay, here how many number of bonding molecular orbitals are there here? 1 2 3 4 5 bonding molecular orbitals are there, and which consists of how many electrons? 2 4 6 8 10, means 10 BMO electrons ide, followed by 2 4 plus 2 6 anti-bonding molecular orbital electrons ide. So which is the question here? The number of anti-bonding electrons in O2 molecules are, how many anti-bonding electrons are there here? 6 electrons. Okay, either this question will be solved based on this property, or else we can solve it by using a simple trick, that is how can we calculate the bond order? Bond order can be calculated by using half into NB minus NA ಅಲ್ವಾ. ಹಿಯರ್ ನಮ್ಗೆ ಗೊತ್ತಿದೆ ಆಕ್ಸಿಜನ್ ಅನ್ನ ಬಾಂಡ್ ಆರ್ಡರ್ 2 ಇರ್ತದೆ ಅಂತ. ಓಕೆ, ಬಾಂಡ್ ಆರ್ಡರ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಈಸ್ ಹೌ ಮಚ್? 2. ಹಿಯರ್ ಹಾಫ್ ಇಂಟು ಓಕೆ ಎನ್ ಬಿ ವ್ಯಾಲ್ಯೂ ಮತ್ತು ಎನ್ ಎ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂದರೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಬಾಂಡ್ ಆರ್ಡರ್ 2 ಆಗುತ್ತೆ. ಇಫ್ ಎನ್ ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 10 followed by Na is equal to 6, 10 minus 6 equal to 4, 4 by 2 is 2. Here in this type also we can calculate the number of bonding electrons and the number of anti-bonding electrons. In both the way we can calculate it. Okay, which is the correct option here? Option 2, that is 6 electrons are there as anti-bonding electrons. Second option will be the correct option. So the next one. Yes, the wave functions of 1s orbitals of 2 hydrogen atoms are psi A and psi B. Psi A and psi B are linearly combined to form 2 molecular orbitals sigma and sigma star. Which of the following statements are correct? Okay, here they have given psi A and psi B are the 2 wave functions. ಈ ಎರಡೂ ವೇವ್ ಫಂಕ್ಷನ್ಗಳ ನಡುವೆ ಲೀನಿಯರ್ ಕಾಂಬಿನೇಷನ್ ಆಗ್ತದೆ. ಓಕೆ, ದಿಸ್ ಈಸ್ ಎಕ್ಸ್ಪ್ಲೈನ್ಡ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ MOT. MOTಲಿ ಏನಾಗ್ತದೆ? ವಿ ಹ್ಯಾವ್ ಟು ಕಂಬೈನ್ ದಿ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್ ಇನ್ ದ ಲೀನಿಯರ್ ಕಾಂಬಿನೇಷನ್. LCAO ಮೆಥಡ್, ಲೀನಿಯರ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್ಸ್, ಓಕೆ, ಈಸ್ ಡನ್ ಯೂಸಿಂಗ್ ದಿಸ್ MOT. Okay, what is the question? These two orbitals are combined each other, linearly combined each other. With respect to that, two molecular orbitals are going to be formed, that is sigma and sigma star molecular orbitals are formed. With respect to that formation, what will be the correct sentence or what will be the correct property of this? The option 1 is sigma star is equal to psi A minus psi B. Here we already know that sigma stands for what? Psi A plus psi B. That means that represents the constructive interference of two waves. Or sigma star represents psi A minus psi B. That means that represents the destructive interference of two waves. That means option 1 is correct here. And the second one, in a sigma orbital, one nodal plane is present in between the two nuclei. Okay, nodal plane means what? That is the plane where we cannot have a electron density at that position. Okay, sigma bonds formation agide antandre alli in between the two atoms there is no formation of any nodal planes or nodal surfaces takes place. Okay, in between sigma bonds in between two atoms there is no formation of nodal planes. Okay, because the electron density is present in between the two internuclear axis. Internuclear axis naduvane electron density irodrinda where we cannot find any nodal planes here. That means second option is the wrong option. And the third one, the energy of sigma orbital is lower than that of energy of sigma star orbitals. That already we know that sigma, that means BMO, sigma star, that means ABMO. Always energy of ABMO is greater than BMO and the stability of ABMO is less than that of BMO. Okay, that means third option will also be the correct option, and that means option 1 and option 3 are correct here. Okay, that means which option is correct here? The last one, that is given as 1 and 3 only. Option 4 will be the correct option here. Clear? Yes. The next one. Yes, the next question is like this: which one of the following has pseudo inert gas configuration? That means which one of the compound has a PNGC, that means pseudo noble gas configuration or pseudo inert gas configuration, both are same. Okay, in our periodic table we are going to observe three types of stabilities. First one is if the elements have 2 electrons in their valence shell, means that is duplet configuration, that is the stable configuration. If the elements has 8 electrons in their valence shell, that means that is octet configuration. Suppose if the elements have 2, 8, 8, 10 configuration in their valence shell. Okay, this configuration ಅವು ಹೊಂದಿದ್ರೆ ಅವುಗಳನ್ನು ನಾವೇನಂತ ಕರಿತೇವೆ? ಸೂಡೋ ನೋಬಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆರ್ ಸೂಡೋ ಇನರ್ಟ್ ಗ್ಯಾಸ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂತ ಕರಿತೇವೆ. ಅಮಾಂಗ್ if you consider Na plus we have in sodium atom we have 11 electrons, with the loss of 1 electron we are having 2-8 configuration, right? Okay, which configuration it belongs to? Octet rule. Followed by the second Cu plus. Atomic number of Cu is 29, with the loss of 1 electron it becomes 28. That means its configuration is 2, 8, 8, 10 it is. And the third option, that is K plus, it is also having 2, 8, 8 configuration, followed by S minus 2, that is also having 2, 8, 8 configuration. But the only element having 2, 8, 8, 10 configuration is, that means D orbitals anna ondiro element ಇಲ್ಲಿ ಯಾವುದಿದೆ ಅಂದರೆ Cu plus ಇದೆ, and that element which is having pseudo inert gas configuration. So which is the correct option here? Option second will be the correct option, that is Cu plus. Okay, next. The next question is the geometry of H2S and its dipole moment are. So which is the question here? H2S will be the given question. According to them, we have to identify the geometry and we have to represent its dipole moment. Okay, in order to identify the hybridization or in order to identify the geometry of the molecules, we have to find out the geometry of the molecule by using hybridization. First we have to identify the hybridization. So here sulfur will be the central atom, value of X will be half into number of valence electrons on the central atom sulfur or 6 plus number of monovalent attached to the sulfur or 2. Molecule being neutral which do not carries any type of charges, that is 6 plus 2 8, 8 by 2 is 4, value of X is 4. If the value of X is 4 means it becomes sp3 hybridization. Okay, the process is still not over. We have to identify the lone pair of electrons. We have to identify the lone pair of electrons by using X minus number of terminal atoms. Number of what? Terminal atoms. What will be the value of X? Value of X is 4 minus number of terminal atoms are how much? 2. That means this H2S molecule, sulfur will have 2 lone pair of electrons. On central atom sulfur, it contains how many lone pairs? 2 lone pairs here. Okay, what is the shape of the molecule when the central atom has sp3 hybridization along with 2 lone pairs? ಏನು ಬರ್ತದೆ ನೋಡಿ, sp3 sulfur H with 2 lone pair of electrons means it must have angular shape. Okay, angular shape or T shape or bent shape. ಯಾವ shape ಅನ್ನಾದರೂ ಕೊಟ್ಟಿರ್ಬೋದು, both are same, angular T or sorry bent shape ಯಾವುದನ್ನಾದರೂ ಕೊಟ್ಟಿರ್ಬೋದು. Okay, next here one thing is clear now, which is having angular shape. Another one is regarding the dipole moment. So the moment of bond dipole takes place from here, from less electronegative to more electronegative. Again here also from less electronegative to more electronegative. The direction of dipole moment is towards the lone pairs. That means moment of bond dipoles are all in the same direction. Same direction ಇರೋದ್ರಿಂದ ಯಾವ ಕಾರಣಕ್ಕೂ ಅಲ್ಲಿ ಬಾಂಡ್ ಡೈಪೋಲ್ ಕ್ಯಾನ್ಸಲ್ ಆಗೋದಿಲ್ಲ. ಮ್ಯೂ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಹಿಯರ್. ಯಾಕೆಂದರೆ ಇಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಕ್ಯಾನ್ಸಲೇಷನ್ ಆಫ್ ಬಾಂಡ್ ಡೈಪೋಲ್ಸ್ ಆಗೋದಿಲ್ಲ. ಮ್ಯೂ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0. ಮ್ಯೂ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಅಂದರೆ ಏನು ಬರ್ತದೆ? ನಾನ್ ಝೀರೋ ಡೈಪೋಲ್ ಅಲ್ವಾ? ನಾನ್ ಝೀರೋ, ಇಲ್ಲಿ 0 ಏನಾದರೂ ಬಂದಿದೆ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್? ನೋ. ಇಫ್ ದೇರ್ ಈಸ್ ಅ ಕ್ಯಾನ್ಸಲೇಷನ್ ದೆನ್ ಇಟ್ ಬಿಕಮ್ಸ್ 0. ಹಿಯರ್ ದೇರ್ ಈಸ್ ನೋ ಸಚ್ ಕ್ಯಾನ್ಸಲೇಷನ್ಸ್ ಆರ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ದಟ್ ಮೀನ್ಸ್ the dipole moment is not equal to 0 here. Okay, so which is the correct option here? It is having angular geometry along with the mu is not equal to 0. Option 1 will be the correct option, that is angular and non-zero dipole moment. Okay, which is correct option. Then the next will be hydrogen bond energy is about. So this is the very easiest question, that is hydrogen bond energy is around 10 kilocalorie. Okay, the first option is correct option, 10 kilocalorie. The next one, yes, the next question will be a bonding molecular orbital is produced by. So the question is BMO, how bonding molecular orbitals are going to be formed. So the bonding molecular orbitals are formed by the constructive interference of 2 waves. Constructive interference of 2 waves, and ABMOs are formed by the destructive interference of 2 waves. This is BMO and this is regarding ABMO. What is the question that is given here? A bonding molecular orbital is produced by, whether BMO is produced by the constructive interference of 2 waves or destructive interference of 2 waves. No doubt BMOs are formed by the constructive interference between the 2 waves. Okay, positive overlap between the 2 waves that results in the constructive interference that results in the bonding molecular orbital. If it is opposite, that means destructive interference adre, that leads to the formation of what? ABMO. So which is the correct option here? Option 2 will be the right one, that is constructive interference of 2 wave functions. So the next question, number of covalent bonds present in tetracyanomethane. Okay, number of covalent bonds present in tetracyanomethane. Okay, in order to find out number of sigma bonds, number of pi bonds, or number of covalent bonds, first we have to know the structure of the molecule. Okay, only knowing the structure of the molecule only we can easily predict the number of sigma bonds, number of pi bonds, or else the number of covalent bonds. So what is the molecule given here? Tetracyanomethane. So this will be the structure of tetracyanomethane. That means CCN4, that is tetracyanomethane. Okay, valency of carbon here it is 4. It is satisfied here 1, 2, 3, 4, and valency of all the carbons and all the nitrogens are satisfied here. Okay, this will be the structure of a tetracyanomethane. Okay, tetracyanomethane. Okay, what will be the question given? How many number of covalent bonds are there here? Okay, illi nodi, not only the covalent bonds, either they may ask identify the number of sigma bonds present in this tetracyanomethane, or else identify the number of pi bonds present in between them, and identify the number of sigma bonds present only in between C and N, or only in between C and C. ಯಾವ ಥರನಾದರೂ ಕ್ವೆಶನ್ಸ್ ಅನ್ನು ಫ್ರೇಮ್ ಮಾಡ್ಬೋದು, ಬಟ್ ವಿ ಹ್ಯಾವ್ ಟು ನೋ ದ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ ಫಸ್ಟ್. ಓಕೆ, ಹಿಯರ್ ದ ಕ್ವೆಶನ್ ಗಿವನ್ ಈಸ್ ದ ನಂಬರ್ ಆಫ್ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ಸ್ ಅಂತ ಕೇಳಿದರೆ. All pi bonds and sigma bonds are considered as covalent bonds. That means we have to consider all the bonds here, either irrespective of their nature. That means either it may be a pi bond or sigma bond, we must consider it as a covalent bond. Okay, how many bonds are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. In this particular molecule 16 covalent bonds are there. Covalent bonds are present. If they ask pi bonds, how many pi bonds are there here? 2, 4, 6, 8. 8 pi bonds. How many sigma bonds are there here? 4, 5, 6, 7, 8 sigma bonds. 8 sigma bonds are there. Like this we can solve the different questions regarding the number of sigma, number of pi, either number of covalent bonds. Okay, which is the correct option here? 16. That means option 3 will be the right one. Okay, is it clear? Yes. Next, so the next question, the species having bond order different from CO is. The question number 90, that is the species which have the bond order different from CO ಅಂತ ಇದೆ. ಅಂದರೆ ಕೊಟ್ಟಿರೋ 4 ಆಪ್ಷನಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಮಾಲಿಕ್ಯೂಲಿನ ಬಾಂಡ್ ಆರ್ಡರು CO ಗಿಂತ ಡಿಫ್ರೆಂಟ್ ಇದೆ ಅಂದಮೇಲೆ 3 ಮಾಲಿಕ್ಯೂಲ್ಸಿನ ಬಾಂಡ್ ಆರ್ಡರ್ ಕಾಮನ್ ಇದೆ, ಒಂದು ಮಾಲಿಕ್ಯೂಲಿನ ಬಾಂಡ್ ಆರ್ಡರ್ ಡಿಫ್ರೆಂಟ್ ಇದೆ ಅಂತ. ಓಕೆ, ಹಿಯರ್ ಇನ್ ಆರ್ಡರ್ ಟು ಐಡೆಂಟಿಫೈ ಇಟ್, ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ನೋ ದ ಬಾಂಡ್ ಆರ್ಡರ್ ಆಫ್ CO ಫಸ್ಟ್. COದ ಬಾಂಡ್ ಆರ್ಡರ್ ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೇನೆ ನಿನ್ನೆ ಹೌ ಟು ಐಡೆಂಟಿಫೈ ದ ಬಾಂಡ್ ಆರ್ಡರ್ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬೈ ನೋಯಿಂಗ್ ದ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದರೆ ಎಷ್ಟು ಬಾಂಡ್ ಆರ್ಡರ್ ಇರುತ್ತೆ ಅಂತ ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೇನೆ. ಓಕೆ, ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಟು ಕೌಂಟ್ ದ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಸ್ಟ್. ಕಾರ್ಬನ್ ಇಟ್ ಕ್ಯಾನ್ ಡೊನೇಟ್ 6 electrons. Number of electrons in oxygen are 8. It is 14. In CO we have 14 electrons. 14 electron system ಗೆ ಏನಿರುತ್ತೆ ಇಲ್ಲಿ? Bond order for 14 electron system is how much? It is 14, 15, 16, 17. 14 is 3 na. 15 means that is 2.5. 16 means 2. This is 1.5. We have to write the bond orders by decreasing 0.5 difference. Okay, like that. The same way 13, 12, 11 and 10. For 13 it is 2.5, again 2, 1.5 and 1. These are the order of bond orders. Okay, here we have 14 electrons now. For 14 electrons the bond order will be 3. ಹೌದಲ್ವಾ? Then what are the options given here? NO. NO means how many number of electrons are there here? Nitrogen can donate 7 electrons, oxygen will have 8 electrons, in total we are having 15 electrons. For 15 electrons, what will be the bond order here? 2.5. 2.5. Second option is NO plus. Okay, NO plus. Nitrogen number of electrons are 7, oxygen number of electrons are 8, followed by positive sign indicates that loss of 1 electron. 8 plus 7, 15, 15 minus 1, that is 14 electrons. 14 electrons means again the bond order is 3. Haudalva? Followed by third one is CN minus. Number of electrons 6 plus 7 from nitrogen. Minus 1 means we have to add it. 7 plus 1, 8 plus 6 is equal to 14. 14 means again the bond order is 3. Next, the last one it is N2. N2 we already know that number of electrons are 14. 14 means bond order will be 3. That means except NO molecule, all the other molecules could represent 3 bond orders. The only change in the bond order is shown by NO molecule. That means which is the correct option here? Option 1 will be the right one, that is NO molecule will have a different bond order than CO molecule. Okay, next. So the next question, which of the following halogens has highest bond energy? Okay, here the option is given, which of the halogen molecule will have highest bond energy? Third one Br, and the fourth one I. Okay, here how can we identify the bond energy of these particular species? Okay, if we want to solve these questions based upon their bond order, all these molecules which should have same bond order, single bond order, the 1 1 1, all are having single bonds. Then how can we compare their energies? Which one's bond energy is much more than following the rest of the molecules? Yaudrದ್ದು ಜಾಸ್ತಿ ಇದೆ, yaudrದ್ದು ಕಡಿಮೆ ಇದೆ ಅಂತ how can we identify it? Here, if we consider atomic size of these two fluorine atoms, atomic size are quite small. Haudalva? Fluorine atoms are having smaller atomic size na. The electrons present in the valence shell of a fluorine atom which starts repulsing each other. Inter-electronic repulsive interactions are maximum in case of a fluorine. If we consider it for chlorine, atomic size of chlorine atoms are quite larger than fluorine and the inter-electronic repulsions are quite less when compared to this. Okay, followed by this Br atom, atomic size is even increases and the inter-electronic repulsions are minimum here, and here also atomic size is even more increased and the inter-electronic repulsions are even minimum. Then how can we predict among FF and CL and BR and II which bond is more stronger in nature? This particular bond, CL bond. ಯಾಕೆ ಅಂದರೆ ಈ ಬಾಂಡ್ಸ್ಗಳ ನಡುವೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ನು ಸ್ಟ್ರಾಂಗ್ ಇರ್ತದೆ, ಫಾಲೋಡ್ ಬೈ ಇಂಟರ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ರಿಪಲ್ಷನ್ ಈಸ್ ಮಿನಿಮಮ್ ವೆನ್ ಕಂಪೇರ್ ಟು ದಿಸ್ ಫ್ಲೂರಿನ್ ಆಟಮ್. ಓಕೆ, ವಿತ್ ದ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ದೀಸ್ ಟೂ ಆಟಮ್ಸ್ ವಿಚ್ ಆರ್ ಟ್ರೈಸ್ ಟು ಟೆನ್ ಟು ಮೂವ್ ಅವೇ ಫ್ರಮ್ ಈಚ್ ಅದರ್, ಒಂದಕ್ಕಿಂತ ಒಂದು ದೂರ ಹೋಗಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾವೆ. ಯಾವಾಗ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಆಗುತ್ತೆ, ದ ಬಾಂಡ್ ಲೆಂತ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಇನ್ಕ್ರೀಸ್ಡ್ ಆ್ಯಂಡ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಬಾಂಡ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಡಿಕ್ರೀಸ್ಡ್. Okay, bond length and bond strength are inversely proportional to each other. If the bond length is more, means that will get less amount of energy to break it. Okay, here the same thing is repeated here. Due to inter-electronic repulsive interactions, bond energy of a fluorine molecule is less than that of a Cl atom, followed by this Br molecule. ಓಕೆ, Br2 ಮಾಲಿಕ್ಯೂಲ್ಗಿಂತ Cl2 ಮಾಲಿಕ್ಯೂಲ್ಗಿಂತ ಫ್ಲೂರಿನ್ ಮಾಲಿಕ್ಯೂಲಿನ ಎನರ್ಜಿ ಇಲ್ಲಿ ಕಡಿಮೆ ಇರ್ತದೆ. ಹೈಯೆಸ್ಟ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಯಾವುದಕ್ಕೆ ಇರುತ್ತೆ ಹಂಗಾದರೆ, ದಿಸ್ Cl2 ಮಾಲಿಕ್ಯೂಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಹೈಯೆಸ್ಟ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಅಮಾಂಗ್ ಹ್ಯಾಲೋಜನ್ಸ್ ಬಿಕಾಸ್ ಆಫ್ ಲೆಸ್ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಆ್ಯಂಡ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಕೂಡ ಮೀಡಿಯಮ್ ಇದೆ. ಅಟಾಮಿಕ್ ಸೈಜ್ ಇರೋದ್ರಿಂದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಬಾಂಡ್ಸ್ ಸ್ಟ್ರಾಂಗ್ ಇರುತ್ತೆ. ಇಂಟರ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ರಿಪಲ್ಷನ್ ಕೂಡ ಮಿನಿಮಮ್ ಇದೆ. ದಟ್ ಮೀನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಟು break this bond. That is why among all halogen series this Cl2 atom will have more bond dissociation energy. Okay, is it clear? Which is the correct option here? Option 2 will be the correct option, that is Cl2 molecule. Okay, next one. Yes, which of the following orders are correct against the property given? The first property is dipole moment. Dipole moments of what? NF3 greater than NH3 greater than boron trifluoride. Okay, next. The second option, covalent bond length. Covalent bond length, it follows the order CO greater than NO greater than OH, followed by the third one is bond order of C2 greater than B2 greater than HE2. ಓಕೆ, ಇದರಲ್ಲಿ ಕರೆಕ್ಟ್ ಪೇರ್ ಯಾವುದಿದೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ಸ್ ಆಫ್ NH3 ವಿತ್ BF3, ಯಾವುದಕ್ಕೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಇದೆ, ಬಾಂಡ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಇದೆ ಅಂದರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದೆಮ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಟ್ NF3 ಮಾಲಿಕ್ಯೂಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಮೋರ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ದೆನ್ NH3. ವಿ ಹ್ಯಾವ್ ಟು ಸಿ ಇಟ್ ವೆದರ್ NF3 ಮಾಲಿಕ್ಯೂಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಮೋರ್ ಬಾಂಡ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಆರ್ ನಾಟ್ ಅಂತ. ಓಕೆ, this is NH3 molecule. The shape of the molecule is common for both, but the attachment of atoms are different here. Here nitrogen is less electronegative than fluorine, such that the moment of bond dipoles takes place away from nitrogen and towards fluorine. Here the direction of lone pair is always common, that is towards the lone pairs. Here it is in this direction and the bond dipoles are in that direction. Both are in the opposite direction, but there is no cancellation takes place here because dipole moment of lone pairs, it is different from this bond pairs. Okay, lone pair in a bond dipole, so bond pairs in a dipoles na jote cancel agodilla. Okay, but here nitrogen is more electronegative than hydrogen, such that moment of electrons takes place towards the nitrogen, such that the electron density on this nitrogen atom or the electron negativity on this nitrogen atom, it is going to be increased. Okay, with the increase in the electronegativity, all the bond dipoles are in the same direction. It is also not equal to 0, but its dipole moment is greater than this NF3. Okay, that means NH3's dipole moment is greater than NF3, and such that this is the wrong option. Okay, NF3 is less than NH3 followed by BF3. BF3's bond angle is 0 here. Okay, then here dipole moment of NF3 is less than that of NH3, that is less than BF3. BF3 ಗೆ dipole moment 0 ಇರ್ತದೆ, ಅಲ್ಲಿ bond dipoles cancel ಆಗ್ತದೆ. Okay, that is wrong option. Then the second one is covalent bond length in case of CO, NO and OH. Okay, here CO followed by nitrogen followed by oxygen. Okay, here when we consider the atomic size of this molecule, okay, CO atomic size is quite larger than this set and it is quite larger than this set. Okay, with the increase in the atomic size of the combining atoms, the length of the covalent bond is also going to be increased. ಇಲ್ಲಿ atomic size ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದರೆ internuclear region ಜಾಸ್ತಿ ಆಗ್ತದೆ, length of the bond will be more. Okay, when we compare the atomic size of this two with these two, second set will have lesser atomic size. With a decrease in the atomic size, length of the bond also decreases. That means this will be the correct option that is given. Length of CO is greater than NO followed by OH. Okay, here it is the smallest atom OH, ಅದಕ್ಕೆ ಇದರದ್ದು bond length ಕಡಿಮೆ ಇರ್ತದೆ. This is correct option. and the third one it is. Bond order of C2 greater than B2 greater than He2. How can we calculate the bond order here? C2 means each carbon atom will have 6 electrons na. Here we have 2 carbon atoms, that means we have 12 electrons. 12 electrons ಇದೆ ಅಂತಂದ್ರೆ ಅವುಗಳ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟಿರ್ತದ? that is 2. Bond order is 2. B2 means each boron will have 5 electrons, that means we have 2 borons, that is 10 electrons. 10 electron ಇದೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟಿರ್ತದ? 1.0. Followed by helium 2 molecule. We already know that the molecule helium is not exist because its bond order is 0. Okay, correct order la ideyalva? Bond order of C2 is greater than B2 is greater than helium 2. That means among the 3 options, the only wrong match is the first option, and the second and third will be the correct options. Okay, which is correct here? Option 2 will be the right one, that they have given second and third only. Okay, option 2 will be the right option for this. Next, so the next one, N2 and O2 are converted into monoanions like N2 minus and O2 minus respectively. Which of the following statement is wrong? Okay, here they have given like N2 it is converted into N2 minus and O2 is converted into O2 minus. Andre after the addition of electrons into these 2 molecules, what are the changes in that particular molecule takes place with respect to the bond order, with respect to the bond length, bond strength? What are the changes that takes place after the addition of 1 electron into this N2 and 1 electron into this O2 molecule anta kelidare. Okay, ಏನಾಗ್ತದೆ ನೋಡೋಣ. In N2 molecule, okay, number of electrons are 14. 14 na, each nitrogen can donate 7 electrons. 7 electrons ಇದೆ nitrogen ಅಲ್ಲಿ, 2 nitrogen ಇರೋದ್ರಿಂದ 14 electrons ಆಗುತ್ತೆ. 14 electrons ಆಗೋದ್ರಿಂದ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟು ಬರುತ್ತೆ? For 14 electron system bond order will be 3 ಅಲ್ವಾ? ಬಾಂಡ್ ಆರ್ಡರ್. N2 minus means addition of 1 electron, that means 15 electrons ಆಗುತ್ತೆ. 15 electron ಆದರೆ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟಾಗ್ತದೆ? That becomes 2.5, that is 2.5 ಆಯಿತು. Followed by O2 to O2 minus. O2 ಅಂದರೆ 8 into 2, that is 16 electrons. 16 electron ಇದ್ರೆ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟಿರ್ತದೆ? that is 2. Followed by O2 minus means 17 electrons. 17 electrons means bond order is decreased to 1.5. For 17 it is 1.5 na. Yes, in both the cases bond order decreases from molecules to ions. Monoanionic ions ಗಿಂತ molecules ಇಂದು ಬಾಂಡ್ ಆರ್ಡರ್ ಜಾಸ್ತಿ ಇದೆ ಇಲ್ಲಿ ಅಲ್ವಾ? ನೋಡಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಇನ್ N2 N ಅಥವಾ N ಸಿಂಗಲ್ ಬಾಂಡ್ N ಬಾಂಡ್ ವೀಕನ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ನೋಡಿ ಏನಾಗ್ತದೆ ಇಲ್ಲಿ, ಬಾಂಡ್ ಆರ್ಡರ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಬಾಂಡ್ ಲೆಂತ್. ಹೌದಲ್ವಾ? ಫಾಲೋಡ್ ಬೈ ಬಾಂಡ್ ಆರ್ಡರ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್. ಓಕೆ, ಎಷ್ಟು ಬಾಂಡ್ ಆರ್ಡರ್ ಜಾಸ್ತಿ ಆಗ್ತದೋ ಅಷ್ಟು ಬಾಂಡ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಫಾಲೋಡ್ ಬೈ ಎಷ್ಟು ಬಾಂಡ್ ಆರ್ಡರ್ ಜಾಸ್ತಿ ಆಗ್ತದೋ ಅಷ್ಟು ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಓಕೆ, ಹಿಯರ್ N2 ಏನಾಗಿದೆ ನೋಡಿ, ದೇರ್ ಈಸ್ ಅ ಡಿಕ್ರೀಸ್ ಇನ್ ದಿ ಬಾಂಡ್ ಆರ್ಡರ್ ಅಲ್ವಾ? ಬಾಂಡ್ ಆರ್ಡರ್ ಡಿಕ್ರೀಸ್ ಆಗಿದೆ ಅಂತಂದರೆ ಬಾಂಡ್ ಲೆಂತ್ ಏನಾಗ್ತದೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಹೌದಲ್ವಾ? ಅವ್ರೇನು ಕೇಳಿದ್ದಾರೆ? ಬಾಂಡ್ ವೀಕನ್ಸ್ ಅಂತ. ದಟ್ ರಿಗಾರ್ಡಿಂಗ್ ದಿ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಬಾಂಡ್ಸ್. ವಿತ್ ದ ಡಿಕ್ರೀಸ್ ಇನ್ ದ ಬಾಂಡ್ ಆರ್ಡರ್ ಬಾಂಡ್ ಲೆಂತ್ ಏನಾಗ್ತದೆ? ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಏನಾಗುತ್ತೆ? ವೀಕ್ ಆಗುತ್ತಲ್ವಾ? ಯಾಕೆಂದರೆ ಬೋತ್ ಆರ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಈಚ್ ಅದರ್. ವಿತ್ ದ ಇನ್ಕ್ರೀಸ್ ಇನ್ ದ ಬಾಂಡ್ ಆರ್ಡರ್ ಓನ್ಲಿ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಇನ್ಕ್ರೀಸಸ್ ನಾ. ಹಿಯರ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಡಿಕ್ರೀಸಸ್ ಫ್ರಮ್ 3 to 2.5. ದಟ್ ಮೀನ್ಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಬಾಂಡ್ ವಿಲ್ ಗೆಟ್ ವೀಕನ್ಸ್. Option 1 regarding this particular example is correct. Second one, in O2 minus oxygen bond length increases ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿ, ಇನ್ O2 2 to 1.5 ಆಗಿದೆ, ಡಿಕ್ರೀಸ್ ಇನ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಆಗಿದೆ. ಬಾಂಡ್ ಆರ್ಡರ್ ಆ್ಯಂಡ್ ಬಾಂಡ್ ಲೆಂತ್ ಏನೋ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಬಾಂಡ್ ಆರ್ಡರ್ ಡಿಕ್ರೀಸ್ ಆದರೆ ಬಾಂಡ್ ಲೆಂತ್ ಏನಾಗ್ತದೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದಲ್ವಾ? ಸೊ ಇನ್ O2 ಮೈನಸ್ ಆಕ್ಸಿಜನ್ ಬಾಂಡ್ ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ ಆಯ್ತಲ್ವಾ? ಬಾಂಡ್ ಆರ್ಡರ್ ಡಿಕ್ರೀಸ್ ಆಯಿತು. ಬಾಂಡ್ ಆರ್ಡರ್ ಮತ್ತು ಬಾಂಡ್ ಲೆಂತ್ ಎರಡು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರೋದ್ರಿಂದ ಫ್ರಮ್ O2 ಮಾಲಿಕ್ಯೂಲ್ ಟು O2 ಮೈನಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಬಾಂಡ್ ಲೆಂತ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಇನ್ಕ್ರೀಸ್ಡ್. That is also correct. And the third one is in O2 minus in O2 minus bond order decreases. In O2 minus bond order is decreases na. In O2 we have 2 bond order, O2 minus we have 1.5, so the value has decreased na. That means option third will also be the right one. And the fourth one is N2 minus becomes diamagnetic. So in the previous class also I had already explained how to identify the magnetic nature of the molecules by using the number of electrons. Okay, if the molecules will have even number of electrons, then that becomes diamagnetic. Odd number of electrons, that becomes paramagnetic, with some exceptions, that is with 10 electron and 16 electron system. Okay, ಇಲ್ಲಿ ನೋಡಿ N2 minus becomes diamagnetic ಅಂತ ಹೇಳಿದ್ದಾರೆ. N2 minus ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟಿದೆಯಪ್ಪ? 15 ಇದೆ. ಆಡ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಆಡ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಏನಾಗ್ತದೆ ಅದು? ದಟ್ ಬಿಕಮ್ಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ ನೇಚರ್, ಬಟ್ ಹಿಯರ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಇಟ್ ಆಸ್ diamagnetic. That means option 4 will be the wrong one here, and option 4 will be the right option. ಗೊತ್ತಾಯ್ತಲ್ವಾ? ರಿಮೈನಿಂಗ್ 3 options are correct here. Option 4th will be the wrong one. Okay, and the next question. Yes, in which of the following the hydrogen bond is strongest? It is the simplest question, that is strength of hydrogen bond is greater in case of solid, lesser in case of liquid, and it is minimum in case of gas. Okay, strength of hydrogen bond is greater in solids, followed by liquids, and followed by gases. Okay, which is the correct option here? Option 1 will be the right one, that is hydrogen bonding is strongest in case of solids. So the next one. Yes, the molecule or ion having diamagnetic nature and a bond order of 1.0 is here. You have to make a small correction here. You have to correct diamagnetic into paramagnetic. Okay, the option is, so the question is little bit, you have to make the correction here. So in the question they have given the molecule or ion having diamagnetic nature antide, though, so you have to replace that diamagnetic with the paramagnetic nature. Okay, so the options are, the first one is He2 plus, second one Li2 plus, the third one B2 molecule, and the fourth one is C2 molecule. Okay, here we have to predict the magnetic nature of the molecules here. Okay, here helium 2 plus molecule, each helium atom should have 2 electrons na. Hydrogen helium 2 helium atoms ide andre 4 electrons ಆಯ್ತು. 4 electrons, this positive sign indicates the loss of electrons. How many electrons? 1 electron. 4 minus 1, that is 3 electrons ಬಂತು. 3 electrons, odd number of electron ಬಂದಿದೆ ಅಂದ್ರೆ this is paramagnetic PM. Okay, this is a paramagnetic. Here lithium, each lithium atom will have 3 electrons. Here we have 2 lithium atoms, that means 3 2s are 6 electrons are there. With the positive sign means loss of 1 electron. 6 minus 1 is 5 electrons. 5 electron means this is also odd na. Odd ide antandre ಏನು ಬರ್ತದೆ? paramagnetic nature ಬರ್ತದೆ ಇದಕ್ಕೂ ಕೂಡ. This is also paramagnetic in nature. And here B2 molecule. So B2 molecule should have, each boron atom can have 5 electrons. Here we have 2 boron atoms, means 10 electrons. 10 electron ide antandre this is an exceptional case. Even though that molecule will have even number of electrons, that's magnetic nature is not diamagnetic, instead it can exhibit paramagnetic. This example is most important, that is an exceptional case, and that is frequently asked questions. ನೋಡ್ರಿ, ಎಕ್ಸೆಪ್ಷನ್ ಆಗಿರೋದ್ರಿಂದ O2 ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನ ಮತ್ತೆ B2 ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನ ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಯಾಕೆಂದ್ರೆ ದಟ್ ಲುಕ್ಸ್ ಲಿಟಲ್ ಬಿಟ್ ಕನ್ಫ್ಯೂಷಿಯಸ್. ಓಕೆ, ಇವನ್ ದೋ that contains even number of electrons also, that should not exhibit the diamagnetic behavior, it can exhibit only the paramagnetic behavior. Okay, so the next one, C2. Each carbon 6 electron, 2 carbon atoms are there, so 12 electrons. 12 electrons andre again it is a diamagnetic in nature. Diamagnetic in nature. ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿ B2 ಮಾಲಿಕ್ಯೂಲ್ 10 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದರೆ ಅದರದ್ದು ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟು ಬರ್ತದೆ? 10 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೀನ್ಸ್ ದಟ್ ಈಸ್ 1 ಇರುತ್ತೆ. ಓಕೆ, ಹಿಯರ್ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದರೆ ಅದರಲ್ಲಿ 2 - 1/2 ಬರುತ್ತೆ, ಹೌದಲ್ವಾ? ಎಷ್ಟು ಬರುತ್ತೆ? 1/2 ಅಂದರೆ 0.1 ಬರುತ್ತೆ, ಸಾರಿ 0.5 ಬರುತ್ತೆ. ಹಿಯರ್ ಆಲ್ಸೋ ವಿ ಹ್ಯಾವ್ 0.5, ಹಿಯರ್ 1. C2 means that is also bond order 1 ಬರುತ್ತೆ. So in the given examples, the only molecule with bond order 1 and paramagnetic behavior is B2 molecule. Okay, which is the correct option here? B2 molecule. That means option 3 will be the correct option. So in this question you have to make a little arrangement, that is you have to change that diamagnetic into paramagnetic nature. Okay, yes. So the next question. Yes, the electrovalency of metal atom is maximum in case of. So what are the examples given here? Sodium hydride followed by calcium carbide, magnesium oxide followed by aluminium fluoride. So Na is given here, calcium is given, followed by magnesium is given, at last aluminium is also given. Okay, among all these ions, which metal atom is maximum? Okay, electrovalency of which metal atom is maximum? Okay, which is the possible conditions for electrovalency of metal atoms? Yavudu possible conditions? So that metal atom should have higher charges, positive charges ಜಾಸ್ತಿ ಹೊಂದಿರಬೇಕು. Okay, ಇಲ್ಲಿ ನೋಡಿ, the charge of Na is plus, Ca is +2, Mg is +2, but aluminium it can exhibit +3. Okay, which is maximum electrovalency ಯಾವುದು ಹೊಂದಿದೆ ಹಂಗಾದ್ರೆ? Al+3 ion ಹೊಂದಿದೆ. So which is the right option here? In aluminium fluoride, that means AlF3 molecule, the electrovalency of aluminium is maximum with respect to the other 3 examples, that is sodium hydride, calcium carbide followed by magnesium oxide. So which is the correct option here? Option 4 will be the right one here. Okay, next. So next question will be the total number of electrons that take part in forming bonds in N2 molecules are. Okay, what will be the question here? The total number of electrons that take part in forming the bonds in N2 molecules. This question is very simple, that we have to write the structure of N2 molecule. Structure of N2 molecule is here na, that is trivalent in nature. Each nitrogen will have 3 bonds na, 3 bonds along with one lone pair. Okay, the total number of electrons anta helidare. Okay, 3 bonds means each bond is composed of 2 electrons. 3 bonds means 3 into 2 electrons, that is 6 electrons. Okay, in the N2 molecule 6 electrons irutte. Okay, that 6 electrons take part in forming the bonds. Ee bonds na formation madlikke ಎಷ್ಟು electron ಬೇಕು ಅಂತ ಕೇಳಿದ್ದಾರೆ. We have 6 electrons to form 3 covalent bonds in between 2 nitrogen atoms. Okay, which is the correct option here? Option C will be the correct option, that is 6 electrons are required for the formation of 3 covalent bonds in between N2 molecule. Okay, next. So the next question, yes, next question is regarding the thermal stability of hydroxides. The question is the correct order of thermal stability of hydroxides is. So the question is very simple, that thermal stability of the molecules, thermal stability of the molecules is directly proportional to atomic number. Okay, This you must remember this. Thermal stability of the molecules is depends upon the atomic number. Okay, atomic number. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ನೋಡಿ, what are the atoms that they have given here? We have alkaline earth metals hydroxide here. Okay, atomic numbers of barium idena illi, barium is greater than, strontium is given, followed by calcium, followed by magnesium. Okay, ನಾವೇನು ಹೇಳಿದ್ವಿ, thermal stabilities of the molecules which increases with the atomic number. Here atomic number of barium is greater than strontium, greater than calcium, followed by magnesium. When we comparing it with the hydroxides, barium hydroxide with strontium hydroxide with calcium hydroxide along with the magnesium hydroxide, MgOH twice. Nodi, hydroxide of barium has got more thermal stability, followed by strontium hydroxide, followed by calcium hydroxide, followed by magnesium hydroxide, which is entirely discussed on the basis of what? Atomic numbers. Okay, this barium hydroxide molecule which possesses more thermal stability only because of the higher atomic number of barium atom. This magnesium has got less thermal stability only because of the lower atomic number of magnesium. So in this series, thermal stability follows this order, that is barium hydroxide greater than strontium hydroxide, followed by calcium hydroxide, followed by magnesium hydroxide. That means which is the correct option here? Magnesium hydroxide less than calcium hydroxide, less than strontium hydroxide, less than barium hydroxide. That means option 3, that will be the correct match, that is MgOH twice, calcium hydroxide, strontium hydroxide, followed by barium hydroxide. Yes, the next question. So the next question is, which class of compounds show hydrogen bonding even more than in alcohols? So the question is like this, hydrogen bonding alcohols ginta maximum hydrogen bonding anna yavadu torustade anta. Okay, if you consider phenols, they have given first one, it is phenol, and the second one carboxylic acids or C double bond O OH carboxylic acids. The third one, it is ethers or O or dash, and the fourth one, it is aldehydes or CHO. So these are the general representation of the molecules that they have given. First, which class of compound shows hydrogen bonding even more than alcohols? Okay, how these molecules looks different from alcohols? Okay, in alcohols, in order to involve in a hydrogen bonding, we have only one oxygen atom here, because hydrogen atom takes place in between hydrogen and most electronegative atom like oxygen, fluorine and nitrogen. All these molecules will have oxygen atoms to get involved in a hydrogen bonding, but here we have only one oxygen atom that is equal to this alcohol. Here also one oxygen atom is there, here also one oxygen atom is there, both are having same tendency, followed by this. Here we have two oxygen atoms are there na, one oxygen atom is here, another one oxygen atom is here, both have capability to involve in a hydrogen bonding. But here we have again one oxygen atom, only one hydrogen bonding is possible here, here also one oxygen atom. So the only one example where we have got two oxygen atoms and more tendency towards hydrogen bonding, here it is carboxylic acid. Okay, because of the presence of two electronegative oxygen atoms. That is the reason why these carboxylic acids which shows hydrogen bonding even more than that of alcohols. Okay, you must remember this, because of the presence of two highly electronegative oxygen atoms here. Alcohols will have single oxygen atom, carbon carboxylic acids will have 2 oxygen atoms. Okay, which is the correct option here? Option 2, carboxylic acids will become the right option one. Okay, next. So the next one, yes, which p orbitals overlapping would give a strongest bond antide. Okay, the first one is like this, second one is like this, the third one is and the fourth one is like this. Okay, what is the question here? Which p orbitals overlapping would give the strongest bond ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, ನಾನು ಹೇಳಿದ್ದೇನೆ strength of bond which depends upon the extent of overlapping ಅಂತ. Okay, ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಪ್ರಾಪರ್ ಓರಿಯಂಟೇಷನ್ ಆಗ್ತದೆ, extent of overlapping ಸ್ಟ್ರಾಂಗ್ ಇರ್ತದೆ, ಆ strength of the bond ಸ್ಟ್ರಾಂಗ್ ಇರುತ್ತೆ ಅಂತ. Okay, if you want to make a strong bond means what will be the nature of the bonds that involved, or nature of the orbitals that involved in the bonding? So the nature of bonds or nature of orbitals to get a stronger overlapping means those nature will be that particular orbitals should orient in a proper direction. Okay, they should have proper symmetry. Combining orbitals ಗಳ ನಡುವೆ ಪ್ರಾಪರ್ ಸಿಮೆಟ್ರಿ ಇದ್ದಾಗ ಮಾತ್ರ ಫಾರ್ಮೇಷನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಬಾಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಇರ್ತದೆ. ಹಿಯರ್ ವೆನ್ ವಿ ಲುಕ್ ಇನ್ ಟು ದಿಸ್ ಈಸ್ ಇನ್ ಒನ್ ಸಿಮೆಟ್ರಿ, ದಿಸ್ ಈಸ್ ಅನದರ್ ಸಿಮೆಟ್ರಿ. ಪಿ ಆರ್ಬಿಟಲ್ ಸಿಮೆಟ್ರಿ ಬೇರೆ ಇದೆ, ಇ ಪಿ ಆರ್ಬಿಟಲ್ ಸಿಮೆಟ್ರಿನೇ ಬೇರೆ ಇದೆ. ಬೋತ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಅ ಬಾಂಡ್ ಬಟ್ ದಟ್ ವಿಲ್ ನಾಟ್ ಮೇಕ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡ್. ಓಕೆ, ಹಿಯರ್ ದಿಸ್ ಬಾಂಡ್ ಈಸ್ ಫಾರ್ಮ್ಡ್ ಲೈಕ್ ದಿಸ್. This bond is formed like this, but here the orientation of bonds are different. Here orientation of bond is different because at this position of the p orbital, that position is called nodal plane. Nodal plane andre ಆ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇರೋದಿಲ್ಲ ಅಂತ. That is the place where we are going to have a least probability to find the electron. That is why this is also gives the wrong one, because orientation of the orbitals is different here. Both are orient in a different orientation. Here also. And the third one, both the p orbitals are orient in the same direction. Both are having same symmetry. And if these two atomic orbitals overlap each other, then that will give a strongest overlap. Okay, and here also such combinations are not possible. Okay, both the p orbitals should overlap like this. Both undergoes sidewise overlap and not like this. So which is the correct option here? Option third will be the right one, and which can form the strongest bond because of the same symmetry between the combining atomic orbitals. So which is the correct option here? Option 3 will be the correct option. Okay, next. So the next one, the correct order of strength of hydrogen bond is, the correct order of strength of hydrogen bonds is, I had already gone through this concept. Hydrogen bond, it can takes place only with the most electronegative atoms like oxygen, fluorine and nitrogen. And strength of hydrogen bond which depends upon the electronegativities of combining most electronegative atoms. Here if the bond takes place between HF, it is stronger than bond between HO is bond between HN. Okay, we should not represent them like this. We have to represent it with a dotted symbols. HF greater than HO is greater than HN because of the electronegativity difference. Okay, we can easily predict the strength of hydrogen bond by using their electronegativity difference. Here fluorine atom is more electronegative than oxygen than nitrogen. That is why this fluorine with hydrogen can form more stronger bond. With oxygen with hydrogen, then nitrogen with hydrogen. Oh, which is the correct option here? HF bond is stronger than HO bond, stronger than HN bond. So which is the right option here? Option 1 will be the correct option, that is HF greater than HO greater than HN. Okay, next. So the next question, that is, which of the following is not a property of a covalent compounds? So what are the properties of covalent compounds? Okay, the very first option, that is they are low melting points anta ide. Okay, they have low melting points, followed by they are not electrical conductors, followed by they exhibit space isomerism, and the last one, they undergo chemical reactions quickly. So the first three options are correct with respect to the covalent compounds because they have low melting points, because if you consider ionic bond, that bond is formed in between the positively charged cation and negatively charged anion, where in between them there is a strong electrostatic force of attraction is there, electrostatic force of attraction. Okay, ಈ force of attraction break ಮಾಡಲಿಕ್ಕೆ we have to apply more amount of energy in case of a melting point and boiling point. In the form of melting point and boiling point, excess amount of energy is utilized for ionic bond, but covalent bond, they possess lower melting points because it is formed in between the two non-metals. ಎರಡು non-metals ನಡುವೆ reaction ಆಗಿರೋದ್ರಿಂದ strength of the bond is little bit weak when compared to that of ionic. But covalent bond, it is also a strongest bond, but when comparing it with the ionic bond, it is quite lower stability, or which is less strength. Okay, the first one is they have low melting points, that is correct option. Second one, they are not electrical conductors because they do not possess the charges. Okay, clear positive and negative charges ಅಥವಾ clear ions ಅನ್ನು ನಾವು produce ಮಾಡೋದಿಲ್ಲ. Third one, they exhibit a space isomerism. What is meant by this space isomerism? These particular covalent bonds, they have, if you consider two molecules with the same molecular formula, means that two molecules, even though they are having same molecular formula, they can differ by the arrangement of atoms in their space. Spatial arrangement of atoms with respect to the covalent compounds is different. That is why, that is the nature of space isomerism that can be shown by covalent compounds. The only nature that the covalent compounds that will not show here, it is they undergo chemical reactions quickly. So if there is a covalent bond formed between two atoms, means that is stronger bond, so that cannot broken very easily by giving less amount of energy. ಯಾವ ಬಾಂಡ್ಸ್ ಬೇಗ ಬ್ರೇಕ್ ಆಗ್ತವೋ ಅವುಗಳು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಈಸಿಯಾಗಿ ಇನ್ವಾಲ್ವ್ ಆಗ್ತವೆ, ಬಟ್ ಹಿಯರ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಇಸ್ ಸ್ಟ್ರಾಂಗರ್ ಆ್ಯಂಡ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಸಮ್ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಟು ಗೆಟ್ ಬ್ರೇಕ್ ದಿಸ್ ಬಾಂಡ್. ಓಕೆ, ಈ ಬಾಂಡನ್ನು ಬ್ರೇಕ್ ಮಾಡಲಿಕ್ಕೆ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಅವು ಈ ಸಿಂಪಲ್ ಆಗಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಲ್ಲ. ಓಕೆ, ದಟ್ ಈಸ್ ವೈ ಆಪ್ಷನ್ 4th ವಿಲ್ ಬಿ ದ ರಾಂಗ್ ಒನ್. ಓಕೆ, they undergo chemical reactions quickly, that is not the property of covalent compounds. Okay, that is the right option. And the next question, the number of ionic, covalent and coordinate bonds present in NH4Cl molecule. What is the structure of NH4Cl molecule? NH4 plus Cl minus. This will be the structure of NH4 molecules. Here we have to identify how many number of ionic bonds, how many number of covalent bonds and how many number of dative bonds are present or coordinate bonds are present anta. Okay, nodi, due to the generation of ions, there is a formation of ionic bond between this N and Cl takes place. That is why one ionic bond is there, one ionic bond, followed by 1, 2, 3 covalent bonds are there here, because those covalent bonds are formed between the mutual sharing of electrons between nitrogen and hydrogen, again nitrogen with hydrogen. These three are the covalent bonds, and the rest one bond is formed by the complete donation of the lone pair of electrons, means these two lone pair of electrons in nitrogen which are utilized for the formation of a single bond. That nature of that bond is called coordinate bond. So among NH4Cl molecule, there are three types of bonds are present. One ionic bond is there, and three covalent bonds are there, along with one coordinate bond is there. So which is the right option here? Option 1 will be the correct option, that is 1, 3, 1. Okay, option 1 will be the right option given. So the next one. The electronic configuration or electronic structure of 4 elements A, B, C, D are given. So the tendency to form electrovalent bond is maximum in, okay, the first example is 1s2, second one 2s2 2p2, third one 1s2 2s2 2p5 it is, and the last one 1s2 2s2 2p4. ನೋಡಿ, ಇದರಲ್ಲಿ ಅಯಾನಿಕ್ ಬಾಂಡನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ which is the most suitable element or which is the most suitable configuration ಅಂತ ಕೇಳಿದ್ದಾರೆ. So here in the first example, this orbital is completely filled with capacity, that is with the duplet configuration, duplet, that is stable, no need of making the bonds. And the second one 2s2 2p2. So in order to get ns2 np6, we need to apply or we need to add more 4 electrons into this shell. ಇಲ್ಲಿ 2 electron ಮಾತ್ರ ಇದೆ. In order to make it to ns2 np6, we have to add 4 electrons. So 4 electrons ಅನ್ನು add ಮಾಡಬೇಕು ಅಂದರೆ we have to apply more amount of energy is utilized. So that is also not possible condition. So the third one 1s2 2s2 2p5. So this is the electronic configuration of a 17th group elements. ಹೌದಲ್ವಾ, halogen group elements in a configuration ಇದು. Okay, here they used to require only one electron, ns2 np5 is there. In order to convert it into ns2 np6, it requires only one electron. Even after the addition of single electron only, this particular configuration should attain the stable noble gas configuration. That is why, which is the most suitable condition to make electrovalent bond or to make ionic bond means option 3rd will be the correct option. So here 2p4 is also there, we can form a bond, stable bond here, but in order to make it to 2p6, we have to apply 2 bonds here, 2 electrons here, but here we have to apply only 1 electron. That is why this configuration will be the most suitable configuration to involved in a electrovalent bond or ionic bond. Okay, which is the correct option here? Option 3 will be the right one here. So the next question. Which one of the following would have permanent dipole moment? So the next question, which of the following would have permanent dipole moment? Okay, so here one thing you must remember here, the molecules with dipole moment 0, ಅವುಗಳಿಗೆ permanent dipole ಅಂತ ಕರೆಯೋದಿಲ್ಲ. Okay, and the molecules whose dipole moment is not equal to 0, they were called permanent dipoles. ಓಕೆ, ಇವುಗಳಲ್ಲಿ ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಗೆ ಮ್ಯೂ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಬರ್ತದೋ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು, ಆ್ಯಂಡ್ ದಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್. ಓಕೆ, ದ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ದಟ್ ಈಸ್ boron trifluoride. Here moment of bonds takes place like this. If you consider net dipole moment, that is equal to 0 here because of the cancellation of bond dipoles. ಇವೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗೋದ್ರಿಂದ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಇರೋದ್ರಿಂದ ನೆಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0 ಹಿಯರ್. ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಒನ್, silicon tetrafluoride, Si F here. So among this, silicon is less electronegative than fluorine, so the moment of bond dipole should be like this, here towards the fluorine, here also towards the fluorine. These two bond dipoles are in opposite direction, will cancel with each other, and these two bond dipoles are in moving in opposite direction, which will cancel each other, and their net dipole moment is equal to 0. Okay, and the third one, SF4 molecule. So in SF4 molecule, hybridization of the molecule will be SF4 andre S ಅಲ್ಲಿ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ವೇಲೆನ್ಸಲ್ಲಿ, ಪ್ಲಸ್ ಮೋನೋವೇಲೆಂಟ್ ಆಟಮ್ಸ್ 4 ಇದೆ. ಓಕೆ, ಡಿವೈಡ್ ಬೈ 2, 6 + 4 10, 10/2 ಅಂದರೆ 5 ವ್ಯಾಲ್ಯೂ, ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ 5 ಅಂದರೆ ಏನಾಯಿತು, sp3 ಡಿಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಯಿತು. ಓಕೆ, ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು ಬರುತ್ತೆ, ಎಕ್ಸ್ 5 ಇದೆ, ಅದ್ರ ವ್ಯಾಲ್ಯೂನ ಟರ್ಮಿನಲ್ ಆಟಮ್ಸಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. 5 - 4 = 1. ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟಾಗ್ತದೆ, ದಟ್ ಈಸ್ 1. sp3d ವಿತ್ ಸಿಂಗಲ್ ಲೋನ್ ಪೇರ್ ಅಂತಂದರೆ ಯಾವ ಶೇಪ್ ಬರುತ್ತೆ, ಸೀಸಾ ಶೇಪ್ ಬರುತ್ತೆ. ನೆನಪಿದೆಯಾ, ಎಸ್ that is the seesaw shaped. Here the dipole moment of this lone pair is different from these bond dipoles. Here this dipole is cancelled with this dipole, no doubt, but these two bond dipoles does not cancel with these two. That is why mu of this molecule is not equal to 0. Net dipole moment for SF4 molecule is not equal to 0. Okay, ಅಂದಮೇಲೆ ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲ್ ಆಗ್ತದ ಇದು, mu is not equal to 0. ಹೌದಲ್ವಾ? ಸೊ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಒನ್ ಮೋರ್ ಮಾಲಿಕ್ಯೂಲ್ ದಟ್ ಈಸ್ XeF4. XeF4 ಅಲ್ಲಿ ಏನು ಬರ್ತದೆ, sp3d2 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇರುತ್ತೆ. XeF with two lone pairs. Lone pair of one bond dipole moment which cancel with other na, ಇವೆರಡು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತವೆ. Followed by these bond dipole and this bond dipole cancel with each other, and this bond dipole and this bond dipole cancel with each other. Mu net is equal to 0. Okay, so in these particular examples only SF4 molecule will have bond dipole which is not equal to 0, and rest of the molecules will have dipole moments equal to 0, since all those molecules other than SF4 have not permanent dipole moment. The only molecule exhibiting the dipole moment permanently is a SF4 molecule, which is the correct option, that is SF4. Third option will be the correct option. This is one of the most important question that you must remember it. Okay, next. So the next question, that is, which of the following option is correct? State T for true and F for false. Okay, the first option is dipole moment is a vector quantity, that is it has both magnitude as well as direction. Obviously that is the correct option, that is we all know that dipole moment is a vector quantity. Okay, then second option, carbon dioxide is a non-polar because the net dipole moment is 0. That we already know it. C double bond O, C double bond O. This is the structure of carbon dioxide. So this will be the structure of carbon dioxide. So if you consider the bond dipole moments, carbon is less electronegative such that the moment of bond dipole takes place from carbon to most electronegative oxygen here. Both bond dipoles are moving with the opposite direction such that there is a cancellation of bond dipoles takes place, and mu is equal to 0. Bond dipoles ಅಥವಾ dipole moment 0 ಇರ್ತದೆ. Followed by, that means first statement is true and the second statement is also true. And the third one, generally in any molecule as bond angle increases, dipole moment also increases. Nodi, bond angle ಇಲ್ಲಿ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಇಷ್ಟಿದೆ ಅನ್ಕೊಳ್ಳಿ. ಹಿಯರ್ ದ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಈಸ್ ಲೈಕ್ ದಿಸ್. ಈಸ್ ದಿಸ್ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಅಫೆಕ್ಟ್ಸ್ ದಿ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್? No. Dipole moment and bond angle are not related to each other. Irrespective of the bond length, bond dipole moment is common here. Okay, bond length ಎಷ್ಟಿದ್ರೂ ಕೂಡ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಬಾಂಡ್ಸ್ ನೋಡಿ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಲೆಂತ್ ಇಷ್ಟಿದೆ, ಈ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಲೆಂತ್ ಇಷ್ಟಿದ್ರೆ ದಟ್ ಮೇಕ್ಸ್ ನೋ ಡಿಫರೆನ್ಸ್. ಓಕೆ, ಬಿಕಾಸ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ವಿಚ್ ಎಂಟೈರ್ಲಿ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಬಾಂಡ್ dipoles, not on the length between them. That is why option 3 will be the wrong one, that is false. And the fourth one, we can determine the percentage of ionic character with the help of dipole moment. Obviously we can calculate the dipole moment by using ionic character by using the dipole moment. Okay, next, which is the correct option here? T, F and T. Which is the correct option here? Option 2 will be the correct option, that is T, F and T. Okay, so the next question. Yes, which of the following hybridization is known as trigonal hybridization? So obviously sp3 is tetrahedral, sp is linear, and dsp2 that is regarding with the coordination compounds, and sp2 is with the trigonal planar hybridization. Okay, which is the correct option here? Third, sp2 hybridization will show the trigonal planar shape. And the next one, yes, the molecule with the zero dipole moment is, okay, the molecule with the zero dipole moment. ನೋಡಿ, ಬಾಂಡ್ ಡೈಪೋಲ್ ಅಥವಾ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಮೇಲೆ ಒಂದು ಕ್ವೆಶನ್ ಬಂದೇ ಬರ್ತದೆ. Okay, that is the most important topic in chemical bonding. Every year in Neet and JEE questions, one question is must be arised from dipole moment concept. Okay, first one, which is the question here? The molecule with zero dipole moment is, the first option ClF3, second one BrF5, and the third one IF7, and fourth one ClF. So first we have to identify the shapes of these molecules. ClF3 means, okay, Cl ನೋಡಿ, V plus M minus C plus A. ಎವ್ರಿ ಟೈಮು ಈ ಫಾರ್ಮುಲಾನ ಹಾಕ್ಕೊಂಡು ಟೈಮ್ ವೇಸ್ಟನ್ನು ಮಾಡಬಾರ್ದು. ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇನ್ ಅವರ್ ಮೈಂಡ್. ದಟ್ Cl, the central atom is Cl here. Valence electrons in Cl are 7 plus monovalent atoms attached to the fluorine are 3. 7 plus 3 by 2 is 10 by 2 is sp3d. sp3d means sp3d with lone pair of electrons ಎಷ್ಟು ಬರುತ್ತೆ? 5 ಬಂದಿದೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ x. 5 minus 3 ಟರ್ಮಿನಲ್ ಆಟಮ್ಸ್ 3 ಇರೋದ್ರಿಂದ sp3d with 2 lone pairs ಬರುತ್ತಿದೆ. 2 lone pairs followed by brf5. again 7 plus 5 12. 12 by 2 is 6. 6 means sp3d2 hybridization. Number of terminal atoms 5 ಇದೆ. That means value of x 6 ಇರೋದ್ರಿಂದ 6 minus 5 equal to 1, that is single lone pair. ಇಲ್ಲಿ single lone pair ಇರುತ್ತೆ. along with that IF7, 7 plus 7 2 ಎಷ್ಟಾಗ್ತದೆ? 14 by 2 is 7. that means sp3d3 hybridization. x ವ್ಯಾಲ್ಯೂ 7 ಇರುತ್ತೆ, ಟರ್ಮಿನಲ್ ಆಟಮ್ಸು 7 ಇದೆ. 7 minus 7 equal to 0. 0 lone pairs ಇದೆ. 0 lone pairs followed by ClF. ClF is simply a covalent molecule. Covalent bond is formed between these two. Okay, here next zero dipole moment. Structure of ClF3 ನೋಡಿ, ಇಲ್ಲಿ ಏನು ಬರ್ತದೆ? sp3d ಅಂದರೆ ಏನು? ಟ್ರೈಗನಲ್ ಬೈಪಿರಮಿಡಲ್ ಜಾಮಿಟ್ರಿ ಬರಬೇಕು, ಬಟ್ 2 ಲೋನ್ ಪೇರ್ಸ್ ಇರೋದ್ರಿಂದ ಇಟ್ ವಿಲ್ ಶೋ ಟಿ ಶೇಪ್. ದಟ್ ಮೀನ್ಸ್ Cl ಎಫ್ 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 ಟಿ ಶೇಪ್, ಈ ಥರ ಶೇಪ್ ಬರುತ್ತೆ. ಓಕೆ, ಇಲ್ಲಿ dipole moment of these lone pairs which does not cancel with this bond pairs, that is why mu is not equal to 0. ಈ ಮಾಲಿಕ್ಯೂಲ್ದು ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ 0 ಬರೋದಿಲ್ಲ ಬಿಕಾಸ್ ಬಾಂಡ್ ಡೈಪೋಲ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗೋದಿಲ್ಲ. ಫಾಲೋಡ್ ಬೈ BrF5 sp3d2, that means octahedral shape ಇರಬೇಕು, but because of the presence of a single lone pair that structure has been changed into trigonal pyramidal ಅಥವಾ square pyramidal shape ಗೆ ಬರ್ತದೆ. So BrF5, this is the structure where its bond dipole of lone pairs does not cancel with each other since their value is also not equal to 0. Dipole moment of this molecule kuda 0 irodilla. Okay, then the third one, IF7 with 0 lone pair. IF7 with 0 lone pair ಯಾವ shape ಇರ್ತದೆ? IF7 with 0 lone pair ಅಂತಂದ್ರೆ pentagonal bipyramidal geometry ಇರ್ತದೆ. So IF7. So here iodine is less electronegative than fluorine, so all the bond dipoles are in a opposite direction. This will cancel with each other, this will cancel with each other, the resultant of this will like this. Okay, ಇವುಗಳ resultant downwards ಇರುತ್ತೆ, both will cancel each other. cancel ಆದಮೇಲೆ ಏನು ಬರ್ತದೆ? mu is equal to 0 ಬರ್ತದೆ. Okay, the molecule with 0 dipole moment is ಯಾವುದು? IF7 molecule. ಇವುಗಳಿಗೂ 0 ಬರಲ್ಲ, ಇದಕ್ಕೂ 0 ಬರಲ್ಲ. ಇನ್ನು ಉಳಿದಿದ್ದು ಯಾವುದು? CLF, ಅದರಲ್ಲಿ 0 ಇರೋದಿಲ್ಲ, ಯಾಕೆಂದರೆ ಎರಡರ ನಡುವೆನೂ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇರ್ತದೆ. ದಟ್ ಈಸ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0, ದಟ್ ಈಸ್ ಇನ್ ಅ ಸಿಂಗಲ್ ಡೈರೆಕ್ಷನ್. CLF ಅಲ್ಲಿ fluorine most electronegative ಇರೋದ್ರಿಂದ that is moving like this. That is why there is no cancellation takes place. Okay, which will be the right option here? Option 3 will be the right option. Yes. So in the next class we will have a continued session regarding the same concept, that is chemical bonding. Thank you.